You know, when we think about history's great inventions, we usually think about fame or fortune being the driving force, right? Well, the story of the world's first practical mechanical calculator, it's not about that at all. It's the story of a teenage genius who built an incredible machine for one simple reason. He loved his overworked dad. Have you ever just been completely overwhelmed by some boring, repetitive calculation? I mean, we've all been there, staring at a screen until our brain feels like mush. Okay, now imagine doing that 400 years ago, all by hand, with a currency system that seemed specifically designed to drive you crazy. Well, that was the nightmare for one man in 17th century France, and his problem was about to spark a revolution. So, to really get why this invention was so important, we have to start with the problem itself, with the sheer, mind-numbing frustration that inspired the whole thing. Our story kicks off in Rouen, France, way back in the 1630s. The French money system back then was, well, it was a mess. It was nothing like our simple decimal system today. It was this chaotic mix of different bases. So one livre was worth 20 sols, but one sol was worth 12 denaries. Just think about that. Every single tax calculation meant you were constantly doing these complex, annoying conversions. It was a perfect recipe for exhaustion and a whole lot of errors. And right in the middle of this storm of numbers was a man named Etienne Pascal, Blaise Pascal's father. His job was tax superintendent, which meant his days and probably a lot of his nights were spent buried under mountains of figures. He had to add and convert all of these complicated units completely by hand. I mean, can you imagine? It was a soul-crushing, absolutely relentless task. And this unbearable workload is exactly what set the stage for one of history's great inventions, an invention born not from a desire for glory, but from a son's empathy for his father. This is where Blaise Pascal enters the picture. Now, this kid was only 19, but he was already a certified mathematical genius. And watching his father struggle day after day, he didn't just feel bad for him, he was moved to act. He decided he was going to build a machine that could lift this incredible burden. And this wasn't just some weekend project he threw together. To get this thing right, Pascal went through an astonishing 50 different prototypes. 50! Just let that number sink in. That represents years of relentless trial and error, of building and rebuilding and refining. And the journey to get there was just brutal. The first craftsman he hired completely botched the job. So Pascal, this math whiz, had no choice but to teach himself mechanics. He experimented with everything: wood, ivory, copper, constantly redesigning and rebuilding from scratch. Finally, in 1645, he had it, a machine that actually worked perfectly. This invention was such a big deal that in 1649, King Louis XIV himself granted Pascal a royal privilege, which is basically the 17th century version of a patent. It gave him the exclusive right to design and manufacture calculating machines in all of France, a huge official recognition of his groundbreaking work. So what made this machine so revolutionary? Okay, let's pop the hood and look inside. The genius of the Pascaline, as it was called, really came down to two key innovations that were just light years ahead of their time. Before the Pascaline, the main tool for heavy-duty calculation was the abacus. But here's the thing with an abacus. It's totally manual. It requires a lot of skill, and its accuracy depends completely on the person using it. The Pascaline, on the other hand, was a monumental leap forward. It made that crucial carryover step automatic, it was easy to learn, and the machine itself guaranteed an accurate result. The first piece of genius was a mechanism Pascal named the sautoir, which comes from the French word to jump. And this little jumping mechanism was the solution to the single most difficult problem in mechanical calculation: how to automatically carry the one. So how did it work? It was this beautiful, elegant system powered by gravity. Picture this. As one dial turned from 9 to 0, it would lift this little hooked lever up. Then gravity would just pull the lever back down, and as it dropped, its hook would catch and kick the next gear forward by one position. It was a beautiful mechanical chain reaction. The second big innovation was a brilliant mathematical trick to solve a major problem. See, the machine's gears could only turn forward, which is great for addition. But how could it possibly subtract? Pascal used a method called nines complement. Essentially, instead of subtracting a number, the machine adds its opposite. It's an incredibly clever way to turn a subtraction problem into an addition problem. And get this, the same fundamental concept, just in binary form, is still used in computers today.
So you've got this machine, an absolute work of genius, right? But here's the twist. The Pascaline was not a commercial success, not even close. So why on earth did this incredible invention fail to take the world by storm?
In a whole decade, only about 20 of these machines were ever sold. Just 20. Remember, he built 50 prototypes to get it right, but only sold 20. That number tells you a story of an invention that was maybe just a little too far ahead of its time. And there are a few key reasons for this. For one thing, the machines were incredibly expensive to make. We're talking the price of a luxury car today. They were also a bit limited. They could add and subtract directly, but multiplication was a slow, repetitive process. On top of all that, they were a pain to reset to zero. And, being made with 17th century technology, they were pretty delicate and prone to breaking down. But the story doesn't end with a commercial failure. Not at all. Because even though the machine itself didn't sell, its ideas were far too powerful to just disappear. In fact, they laid the groundwork for the technology that all of us use every single day. You can draw a direct line from the Pascaline to modern computing. It inspired Gottfried Leibniz to create a machine that could also multiply and divide. That in turn influenced Charles Babbage's difference engine, which was really a forerunner to the modern computer. Pascal's work was that first absolutely critical step. So Pascal's true legacy isn't the physical box of gears. It's the core concepts he pioneered, things like operating on discrete digits, that automatic carry mechanism, using complements for subtraction. These aren't just historical fun facts. They are fundamental principles that live on the architecture of the very device you're watching this on right now. You know, maybe the most profound insight came from Pascal's own sister. She really understood what he had done. She saw that this wasn't just a box of gears. She wrote that, for the first time, a science that exists entirely in thought was mechanized, finding a way to get reliable answers without any need for human reasoning. In a way, it was the very first step in teaching a machine how to think.